So hi everyone, welcome to Electronics Techie. So today in this video we are going to discuss about the MOSFET. So 1 minute, some unwanted marks will be there. So I will erase here. So the MOSFET. Coming to the MOSFET, the full form of the MOSFET is Metal Oxide Semiconductor Field Effect Transistor. So in this FET, we are going to design the circuit with the semiconductor. So that's why we call it as a metal oxide semiconductor. In that design, so you are going to use metals, and in between the metals you are going to isolate that metals by using oxide layers. So that's why we call it as a metal oxide semiconductor field effect transistor. So let's see what are the things we are going to discuss. So see, we will cover these topics in this video. So what are the topics we are going to discuss is types. What are the types, and the circuit symbols, and the next the working principle, and the next the operating regions which are done in the MOSFET, and the drain current equation. So there is a flow of current, and the output is going to be get at the as the current. So in BJ2 we discuss like current control device. So what is mean by current control device? So the input current is going to be control the output current. So in MOSFET, what we say is, so it is the voltage control device. So voltage current control device is nothing but, so input voltage is going to be control the output current. So whatever the input we are going to given, that will be depends upon the output we are going to get. Okay. So what will happen means, here the current is going to be control the output current. So the major difference between the MOSFET and BJT is like the voltage is going to be control the output current. So next we are going to discuss about the output characteristics, and finally end our video with applications, advantages and disadvantages. So coming to the first one, types of MOSFET. We have depletion mode and enhancement mode. Again in depletion mode we have N channel and P channel. In enhancement also we have N channel and P channel. So what is the difference between the depletion and enhancement? We discuss by seeing the symbols. It will be very easy to understand. So see now. So this is the N channel enhancement. This is the P channel enhancement. First we have to discuss the enhancement mode of operations. So see here what will happen. So there is a gate terminal and the drain terminal and the source terminal. The flow of current is from source to drain. So the direction of the flow of electrons is like drain to source in P channel. So what will happen here? There is a no channel between the drain and source. Initially, no channel between the source and the drain. But in enhanced N channel and P channel depletion mode, so there is a inbuilt channel. So there is a inbuilt channel. So 1 minute, there is a low charge. I will charge it. Wait a minute. So meanwhile, we will discuss about the concept till now we discuss. So what is the thing we are discussed till now? So there is a two types of MOSFETs. So the MOSFET is going to be operating two mode, enhancement mode and depletion mode. So in enhancement, what is the thing? So there is initially a channel, whereas in depletion, there is, in enhancement, there is no, initially there is a no channel. Coming to the depletion, there is a initially channel between the source and the drain. So what will happen if there is a channel, if there is a no channel? So in enhancement, there is no channel. So what will happen? By applying the input voltage, we are going to form the input, by applying the input voltage, we are going to form the channel between the source and drain. So how we are going to form, we will discuss in the working principle. So coming to the depletion region, initially there is a channel. So what will happen when we apply the opposite polarity of voltage, which is going to be depletes the channel, which means whatever the voltage we are going to give, it can widen the channel length and it can use it to improve the current flow more. So what is the disadvantages means, initially there is a channel, so it can easily fluctuate with the DC voltages. If there is any noise voltages, the gate voltage contains it is a input voltage and some it as a it takes as some input voltage and it is also going to be activate easily. So that's why most of the engineers are, whatever the design, we use enhancement only, because enhancement can be controlled by us. In depletion, we can't control the whatever the things is going to be flow. The flow of current we can't control in the depletion region because there is internally inbuilt channel. So inbuilt channel means what will happen? There is a flow of current between the source and drain. Okay. So that's why we prefer only the enhancement mostly than depletion. Okay. So coming to the working principle, so MOSFET has a 4 terminals. What are the terminals? Source, drain, gate, and body. So coming to cross-sectional view, so see here, there is a source and the drain and the body. So body or bulk or substrate, all the terminals same as a named as the same thing. So for gate and the substrate, there is a SiO2 layer for insulation. So if there is any DC voltage are coming outside from the noise, so it can't fluctuate, can't enter into the MOSFET. That's why we have to cover it with the SiO2 layer from prevent from the noise signals. So coming to the things, so let's see here, the gate is electrically isolated from the channel by a thin SiO2 layer. So thin SiO2 layer thin SiO2 layer can be going to be covered in between the gate and the channel. So there is no DC current flow into the gates. That's why there is no chance to flow of current between the gate to the whatever the substrate for DC current. Okay. Applying a positive VGS attracts electrons toward the gate region. So what will happen? Now we are going to apply the positive VGS because there is N channel enhancement mode MOSFET. This is the N channel enhancement mode MOSFET. So what will happen? We are going to apply the positive VGS voltage. So what will happen? The P substrate having electrons. So we have majority charge carriers are holes and the minority charge carriers are electrons. So whatever the minority charge carriers which are present in the P substrate are going to attract towards the positive voltage of the gate. So then what will happen? These electrons are attracted towards the gate and come into the edge of the gate terminal and form a channel. There is a flow of current between the source to drain by using this channel. So when VGS exceeds the threshold voltage, so threshold voltage. So what is mean by threshold voltage? So the minimum voltage which is required to turn on the device or to start the device. So if VGS is less than VTH, the device is turned off. There is no flow of any charge carriers because it can't turn on the device. So whenever the VGS is exceeds the threshold voltage, means greater than threshold voltage, then only our MOSFET is going to be turned on and going to be work properly. A continuous inversion channel is formed along the ID current is going to be flow from drain to source. So the flow of electrons from source to drain and the flow of current is from flow of ID to flow from drain to source. So from drain to source, the flow of current will be there. So see here, drain to source. So see, the flow of electrons is from source to drain. The flow of current is from current is the flow of electrons which is oppositely. So if the electrons are moving in this direction, the flow of current is opposite to the flow of electrons. So that's why the electrons are moving from source to drain and the charge carriers which are, that means current is going to be from drain to source. The gate voltage controls the channel conductivity, acts as a voltage control switch or amplifier. So whatever the gate voltage we are going to apply, input voltage, so is going to be control the output voltage. Okay. Sorry, output current. So it acts as a voltage control switch or amplifier. It acts as a switch or amplifier. So increasing VDS will form a channel, increases ID until the channel pinch off near the drain. So 1 minute I will erase it. So what it will say means, so for so 1 minute. We will erase all the things, then it is clearly to understand. Okay, it's enough, I think. Okay, 1 minute. Okay, what will happen? Increasing VDS. So in VDS also have some voltage. Okay, right? So means the voltage between the source and the drain. Some VDS, they have to apply some voltage which form a channel, increases the ID until the channel pinch off near the drain. So what will happen? Means if you increases the VDS voltage, so then what will happen? So the means whatever the channel which is at the channel is like this. So applying by increasing the VDS, So the channel is going to be narrow at the VDS. So what will happen means by increasing the VDS voltage, the depletion region, so whatever the depletion region is going to be increased at the drain terminal, so the channel is going to be narrow. So the flow of current will be low. So someone say in pinch off region, so in pinch off region, there is no flow of current, but it will be wrong. So there is a minimum flow of current. So we say that it is a minimum flow of current. We can't say no flow of current. So see next what will happen. So the operating regions. So based on the relation between the VGS and VT, some of the relations we are going to divide into the some regions. So cutoff region, triode or ohmic region or saturation region. So in cutoff region, what will happen? There is no flow of current. Why? So our threshold voltage is less than VGS. So what I say, so there is a minimum voltage. You have to turn on the device, that is VTH. If it does not match to that particular voltage also, it can't turn on. So there is no flow of current. So no channel forms, MOSFET is off condition. So there is no drain current. So ID is equal to 0. So coming to the triode or ohmic region. So coming to here, it acts like an open switch. Open switch means there is no flow of current. So switch is off. Off switch, it acts like a off switch. MOSFET acts like a off switch. So coming to the triode region. So it is greater than the threshold region, threshold voltage. So then VDS is less than VGS minus VTH. But whatever the voltage, drain to source voltage is less than VGS minus VTH. We call it as a over drain voltage. So VOV. We can understand properly in next video. But so this is the condition for the triode region. What will happen? The channel formed end to end. So the threshold voltage here, whatever the VGS is greater than the threshold voltage. So whatever the gate voltage we are going to apply is greater than the threshold voltage. So then what will happen? The MOSFET is going to be conduct. The channel is going to be formed. So the flow of current is between the channel source and the drain. So MOSFET behaves like a voltage controlled resistor. So it acts like as a on switch. So in cutoff region, it acts like a off switch. In triode region, it is like a on switch. So coming to the saturation region. Here what will happen? VGS greater than VTH. So which means the threshold voltage, VGS is exceeds the threshold voltage, there is a channel formation. So and VDS is greater than or equal to VGS minus VTH. Whatever the overdrive voltage is going to be less than the VOV less than or equal to VDS. Or we will say like VDS is greater than or equal to VOV. Both are same. So then what will happen? ID nearly independent of VDS. So whatever the flow of output current is definitely independent of the VOD. So means VDS till now the ID depends upon the VDS and VGS like that. So once it enter into the saturation region, it doesn't depend upon the VDS. So use it for the amplification. So in this region, this MOSFET is going to be acts like as an amplification. So coming to the cutoff region, what is the ID current equation? See here, gate to source voltage is below the threshold voltage. So whatever the voltage between the, so this will be the gate here. So what will happen? This VGS value is less than VTH. So there is, it can't match the rule. Means like whenever the VGS is greater than VTH only. So whenever these two are going to be matched or greater than, so VGS is greater than VTH, then only our device is going to be turned on. Otherwise, it can't turn on. So it will less than VT. So what will happen? So there is no flow of current. No inversion channel is formed. There is no channel between this source and drain. And the MOSFET behaves as an open circuit between the drain and source. So there is no channel. So what will happen? There will act like a open switch. Ideally, drain current ID is equal to 0. So practically speaking, there is some leakage of current, some small 1 milliampere, small, very 10 power minus 10, minus 6 milliamp. So whatever the things, so minimum current is going to be flow. So in theoretically, we say that ideally means for studying purpose, we say that no flow of current, ID is equal to 0. So MOSFET acts like open switch, drain and source are electrically isolated. So no current path between the existence of channel. So there is no channel, no of current. So that's why it acts like as a off switch. Open switch is nothing but off switch. So coming to the triode region. So this is the condition we discussed till now. An inversion channel fully connects between the source and drain end to end. So there is a channel formation between the source and drain. Channel acts like a resistor whose resistance is controlled by VGS. So here the channel is acts like a resistor. So the resistance value is controlled by the VGS. So resistor is nothing but what will happen if we control the resistor means resistance means, so indirectly we are going to control the current only. If we increases the resistance, so the current flow is low. If we reduces the resistance, the current flow will be more. So indirectly we are going to control the current. So here the resistor means we are going to control the current. So ID increases almost linearly with VDS for small VDS values, uses the voltage control resistor for analog switching. It acts like a on switch. So whatever the triode region, it acts like a on switch. So the drain current equation ID is equal to Kn VGS minus VT minus VDS whole square by 2. I will write here ID is equal to Kn VGS minus VT into VDS minus VDS whole square by 2. So see here mu Kn is nothing but mu n COX into W by L. So you can simply say it as Kn. Mu n means mobility of the electrons or holes. If it is n channel, mobility of the electrons. If p channel, it is the mobility of holes. So into COX means oxide capacitance, and the W means VD, L means length. So VGS and VDH, we know VGS is the input voltage, threshold voltage, VDS means source to drain voltage. So this is the equation for the triode region. So approximation for the small VDS behaves like a linear, and some conditions will be there. The final main equation will be this thing. So see here what is the condition, it's same. It's approximation for small VDS. So for small VDS it can be approximated to what will it is going to be discussed. ID is equal to Kn VGS minus VT VDS behaves like a linear region. So RDS on equal to 1 by Kn VGS minus VT. So for lower VDS we consider the second term as the 0. Okay. So means smaller number divided by 2 means it become little more small. So we can neglect this term. So for smaller VDS, we consider only the first term one. Okay. So it acts like a resistor. The resistor value is like 1 by Kn VGS minus VT. So coming to the saturation region, this was the condition. So channel pinch off near the drain ends as the VDS increases. Whenever you are going to increase the VDS, there is a pinch off takes place at the drain terminal. So what will happen? The IDS becomes nearly independent of VDS. There is a small flow of current. It is independent of VDS. MOSFET behaves as a constant current source. This region is used for the amplification. It is used for the amplification purpose. So here what will happen? Same is the before. So Kn by 2 VGS minus VT. So consider the previous example. So VDS minus VDS by 2 whole square by 2. See now what will happen means it independent of the, so it is independent of the VDS. So we know the equation, see here in the same slide itself. So VDS is equal to, so greater than or equal to means VGS minus VTH. So now we can write it as VGS minus VT into VGS minus VT. We replace VDS equal to VGS minus VT, that's it. So nothing will more. So minus VGS minus VT whole square by 2. So we turn it as VGS minus VT whole square minus VGS minus VT whole square by 2. So by LCMing these two, so we get VGS minus VT whole square. So that is our final equation. So ID is equal to Kn by 2 VGS minus VT whole square. So I explain this once more, some little bit clumsy. So I will erase all the things. So 1 minute. Okay. So consider the same equation in the what are the things. So ID is equal to Kn. So what are the previous one? I will take VGS minus VT into VDS minus VDS whole square by 2. So see what is the equation here? I use the same here. So now what I am to do, this see the expression. So here VDS is equal to VGS minus VT greater than or equal to, I consider directly as equal to. So now I changes it as the like this. I will replace VDS as VGS minus VT. So VDS minus VT into VGS minus VT. So VDS is directly converted into this term. So and again VDS is replaced with VGS minus VT whole square by 2. So Kn VGS minus VT whole square. So x into x square like that, VGS minus VT into VGS minus VT is equal to VGS minus VT whole square minus VGS minus VT whole square by 2. So now what will happen? We LCM this Kn into 2 VGS minus VT whole square by VGS minus VT whole square by 2. So 2 minus 1 we get 1. So Kn VGS minus VT whole square by 2. So this is our final equation we represent in the saturation region. It acts as like as an amplification. So this is the draining current equation in the saturation region. So coming to the output characteristics. So in cutoff region, the output will be going to be 0. So see here the output is going to be 0. So in the triode region, what is the triode region? So this will be the triode region. So there is a increase in the current according to the voltage we have given. Okay. So then in saturation region, what will happen? It is the saturation region. Okay. So in saturation region, what will happen? Almost the current flow is constant. So there is no much more increase in the current. So because of pinch off, the flow of current is going to be limit and being constant only. There is no further increase. So that is the output characteristics. So coming to the application, it is used in the digital ICs, power electronics, amplifiers, and then switches and relays. So you know that in some regions it acts like a switches. Huh? So that's why we used in the switches and relays, voltage regulators, and RF circuits. These are some of the applications we are going to use the MOSFET. So coming to the advantages and disadvantages. So very high input impedance, negligible gate current. So coming to the advantages, there is a high input impedance. So because of the high input impedance, there is a no flow of current between the gate and the substrate while it is in the off state. So low power consumption and high switching speed. So the power consumption is going to be low. The voltage which are going to apply is little only. So there is a high switching speed. So it can be easily going to be switch on and switch off. There is a speed will be more in the MOSFET coming to the BJT compared to the BJT. Easy to fabricate at very small scales. So for every tiny circuit also you are going to design by using this MOSFET. So no majority carrier storage time, fast switching. So the flow of current is only by majority charge carriers only. So there is no minority charge carriers going to be stored. So that's why the fast switching is going to be there in the MOSFET. Voltage control device, simple to try. So it is a voltage control device. BJT is the current control device. So that for voltage control device, we are going to easily apply the voltage to the circuit. Smaller size enables the high packaging density. So for smaller size, we can accommodate more number of transistors on a single chip. So more transistor means more speed, more reliability, more advantages. So coming to the disadvantages, gate oxide is very thin, susceptible to damage by ESD. So the gate oxide is very, very thin. So some high currents or some high voltages, it may be easily damaged. Low transfer conductance than BJT for same bias current. So there is a transconductance called, we discussed transconductance further videos. So till now you can see for there is a lower transfer conductance compared to the BJT. So next one, performance affected by the temperature variations. So try to answer the transconductance in comment section. So that's why I understand how many of are aware of the transconductance and how many of the need the meaning of the transconductance. So the more number of students are, what are the listeners you are going to listen, however being want this transconductance definition in upcoming video. So according to the comment, according to the anxiety only, I will discuss this transconductance. Otherwise, I will left. So this is some nothing. So just verify how many of them curiosity to listen something. So if they know, okay, no problem. If anyone want the transconductance, comment transconductance. I definitely include. If anyone, one person also, I will include. Performance affected by the temperature variation. So whatever the increase in the voltage we apply, so output current is completely some fluctuations depending upon the temperatures at the particular situation. So parasitic capacitance limit very high frequency performance and the threshold voltage variations across the fabrication process, more complex small signal model and small diodes. So these are the some of the advantages and disadvantages of the MOSFET. So we will end of the video. So till now we completely discuss about the MOSFET and the types of MOSFET and the symbols, working principle and the regions and the diode current output characteristics, applications, advantages and disadvantages. Nearly 10 more topics we are discussing in this video. So if you have any doubts, you can comment on me this. So if you want any particular definition also, any word, anything you feel difficult and need some meaning, some clarification, some understanding. So you can comment for me and I will definitely respond for a small video also, small short also. If you need a small definition, I will make it as a short. If you want a lengthy understanding, I make it as a video. Really, it's my promise to make a video if you want any explanation of particular topic. Not only this, if you want anything related to this CMOS subject, you can comment for it. I will make a video for you. And then thanks for watching and thanks for keep supporting me. And then bye.